Hey, it's Jacob. Welcome to this new video. So maybe you started to learn AI, or you looked online to learn AI, and you couldn't find you found a lot more information that you wanted to, right? Now the problem today is not that you don't have enough information. The problem is that real information, is becoming more valuable because you have too much of information that isn't valuable, right? So all of that is confusing because you need to make the difference between the real information and the information that is going to lead you astray and that you're going to waste your time on. So it's actually extremely important to know what you need to spend your time on versus what you don't need to know in order to move forward, because it's a huge waste of time if you learn the things that are not useful. So here in this video, I want to talk about a scientific method. What's the scientific method to get to the truth is? How do people, scientists, do things in order to know what is true and what is not, right? And this is going to help you basically take that same approach in order to decipher what is to know what's not good, what you shouldn't learn, and versus what you should learn, right? What is not useful versus what is useful. What is kind of like a belief or a religion where people say this is what you need to know because it is what you need to know. This is not. They don't use the scientific method to explain the reasons why you need to know those things versus the things you actually need to know, right? So first, let me explain a little bit what the scientific method. So if you ask people sometimes what they don't really know, that are not really scientific, that don't have that approach, or that just have heard about, they know about what science is, they're gonna say maybe well, science is kind of what's true, right? It sounds like that's kind of the easiest way to define it, right? Science is true. And the weird thing, it's a little bit counterintuitive, but it's actually almost the opposite of that. It's not quite the opposite, but it is kind of it is very different from that, right? It's so scientific doesn't mean true, it means that it can be false. So basically, it means it's falsifiable. So, for example, if you talk about the speed of light, well, you have basically any particle, they cannot go faster to the speed of light, right? So this is just this is a theory, right, from science. So if you want to know if that's true or not, it needs to be falsifiable. So that doesn't mean that it's true or not, but if it's not falsifiable, then you know that it's absolutely not true, right? It has to be falsifiable. In this case, all you have to do is the experiment you need to conduct in order to prove that hypothesis wrong is, well, you take a particle and you make it travel faster than the speed of light, right? And so this is the experiment. It's very clear to demonstrate that this can be false. So that's why this is scientific. Non-scientific work is about having an idea and looking for confirmation of that idea instead of looking for the opposite. So this can sound a little bit counterintuitive again, because most people do that, right? You have an idea and you look for things outside and things in the real world that are going to confirm your hypothesis, and then it looks they come up with tons and tons of data about that is going to confirm that this is true, right? It's look at this stats and look at those stats. It's sure, but that's not scientific though. It sounds weird, right? Because you have statistics, you have mathematical models and a lot of things like that. And even though you have all of that, then it's also not scientific. So that's why we need to be careful, using math, using theories. This doesn't mean that it is scientific. So because the main reason for that is no amount of data can prove something. Again, no amount of data can prove something. This is extremely important because one data point can disprove something, right? There is an asymmetry in knowledge, so it is not equal. So that's the reason why we need to look for falsifiable hypotheses instead of like things that are confirming. We need instead of like looking for more and more and more data in order to prove that thing, the scientific approach is to look for how do you disprove that thing, right? So why am I talking about all of that? Again, to come back to the to like AI and learning about like those type of it can be any skill, right? But like here we're talking about AI right now, and this is about like basically how do you know like that what you're using, what you're learning is going to be false or is going to be not or is going to be good, you know? Do you need to know it, right? Is the main question. So if you have to come up with basically like you have like mathematics and like algorithms, like linear algebra, like data science, statistics, programming, like all of those different fields that you need to learn, right? That's what people are telling you. So the question is this something, is this real? Is this true that you need to learn all of that? So here's the question you need to ask then. It's what would prove you wrong? So this is just to simplify everything that I said earlier. If you want to have somebody that, if you want to make sure that what they were saying at least makes sense from a scientific standpoint, if it has the scientific method, then you need to ask them to design, to ask them like, what are the set of conditions that would falsify your hypothesis? So what would prove you wrong? What would tell you that well, this is actually not true, that you need to learn all of those things in order to move forward? You know, what would prove you wrong? And they have the burden of proof here, where they have to come up with an experiment that would falsify their statement. If they can't do that, then that means it's false, right? Because you need to have a set of conditions that would disprove their hypothesis in this case. So if they can't come up with that, then the experiment is not falsifiable. If it's not falsifiable, then it's not scientific. So it's okay to have beliefs or religion, but we need to understand it for what it is, you know. And a lot of education sometimes has parts of the knowledge that they keep teaching that is a little bit outdated. And so because it's a little bit outdated and it's extremely costly to actually like update everything, it's just costly. Like you need to train people to do that, you know. So this is not necessarily they don't necessarily have your best interest in mind in this case, where they can't afford that cost, you know. So it's better for them to tell you that this is the things that you need to know, even though that's not necessarily true. And so that's the reason why you need to ask yourself that question and keep that in mind every single time you are learning a piece of anything, right? Any type of learning has to go through that filter if you don't want to waste your time. So that's it for this video. If you want to be part of my contacts, you can click on the link in the description. You'll receive free content from me, exclusive content from me. So thank you for watching and see you in the next one.